This lesson is on solving a system of linear equations by elimination. So we've looked at solving a system of linear equations graphically as well as by substitution, and this is a third tool now by elimination. And this is the second tool that we'll look at that is purely algebraic. Substitution was the first tool when we did it algebraically. So let's solve the below system of equations by elimination. Step 1. When solving by elimination, add one entire equation to the other, or subtract one entire equation from the other, in order to cancel out one of the variables. Sometimes you'll need to multiply one entire equation by a number so that you can cancel out one of the variables. Let's label our equations, A and B. Line up the equations so that x's, y's, and constant terms are each in the same vertical line. Notice we have a negative y and a positive y lined up already. This means if we add both equations, those y values will cancel out. So, we're literally lining everything up, and then we're adding one entire equation to the other entire equation. So this is relatively easy when you have everything lined up. So we have negative 3 plus 2x is a negative 1x, minus y plus y here is a 0y. I didn't write that. That canceled out. That's why we did this. And then 5 plus minus 5 is just 5 minus 5, which is just a 0. And so negative x equals 0, and then if you divide both sides by a negative 1 or multiply both sides by a negative 1, you'll get rid of the negative x and it'll become a positive x, and 0, you can't change that, it'll still stay 0, so x equals 0 is the solution for x. And step 2, plug this known value of x into one of the original equations. We want to find out what y is, remember? Be smart and pick one that looks like it will be easier to solve. Note that it doesn't matter which equation is chosen since the x and y values satisfy both equations. That's what makes them the solution. Let's plug into equation B since y is already positive on the left-hand side there, so I figure it'll be maybe saving us one step. So we have our equation B here. Let's plug in 0 for x. So again, anywhere there's an x, you put a brackets and then the 0 for x, so that 2 will go away, 2 times 0 is 0, and then you're just left with y equal to negative 5. So we have x equals 0 and y equals negative 5. These are the x and y values that satisfy both original equations. Let's solve the below system of equations by elimination. Step 1, let's label our equations, A and B. Note that none of the variable terms will cancel out since they have different coefficients. So coefficients, remember, are the numbers in front of the variables. We need to multiply one entire equation, or sometimes both, so that we can make a variable term have the same coefficient value. Let's multiply equation A by 2, so we make the 2x into a 4x. Then it will cancel with the other 4x in equation B when we do our subtraction. So I'm giving a heads up to you now, we're multiplying the entirety of equation A by this 2. We're fine to do that. Remember, we're basically multiplying both sides of the equation by 2, so we're not actually changing it, we're just manipulating it algebraically so that we can use it when we're solving by elimination here. So I've rewritten equation A as double the amount. So this is 2a, and that's fine, as I just mentioned. So we had 2 times 2x is 4x, negative 4y times 2 is negative 8y, and 13 times 2 is 26. And I'm writing b again down here. And now I'm going to subtract the entirety of b from a. Well, 2a. Now, remember, this subtraction here, it's very important to remember, you bracket this whole thing, and that subtract is going to apply to every term inside here when we do our subtraction. So, 4x minus 4x is what we wanted to do to get rid of the x's, negative 8y minus 5y is the same as negative 8y plus 5y. That is negative 3y. And then 26 minus 8 is 18. And then dividing both sides by negative 3 to isolate our y, we get 18 divided by negative 3 is negative 6. So we found out what our y is that satisfies these two equations. Now we need to find the corresponding x. So step 2, plug this known value of y into one of the original equations. Be smart and pick one that looks like it will be easier to solve. In this case, both equations are fairly similar, so it doesn't really matter which one. I chose equation B. So wherever there's a y in equation B, plug in a negative 6 in brackets. So for y, we're putting in negative 6, and then we get 4x minus 5 times minus 6 is positive 30. 8, carry that down. And why are we doing this? We need to find out what the value of x is. So let's get rid of this 30 on the left-hand side here. So we subtract 30 from both sides. 8 minus 30 is 22. And then we still have a 4 stuck to our x here. The only way we can get rid of that 4 is dividing that side by 4. We need to do the same to the other side. And so we have x equal to negative 22 divided by 4. And of course a 2 goes into both top and bottom there. So that reduces down to negative 11 divided by 2. So finally, we have x equal negative 11 over 2 and y equals negative 6. These are the x and y values that satisfy both original equations. So continuing from the last example there, how can we check if this solution is correct? Our x equals negative 11 over 2 and y equals negative 6. Well, we can plug those values into both equations, as I've mentioned before, and see if the equations work out. So let's look at equation A first. We'll plug in x equals negative 11 over 2 and y equals negative 6 there on the left-hand side. And then simplifying that, the 2's cancel here, and you're just left with negative 11. Negative 4 times negative 6 is positive 24. And what's 24 minus 11? That's just 13. So that works out. And let's check that they work in the other equation, B. So we're doing the same thing. Plug in negative 11 over 2 for x, negative 6 for y. And then we have 4 divided by 2 becomes just a 2 on the top. 2 times negative 11 is negative 22. And minus 5 times minus 6 is positive 30. And that equals 8. And what is 30 minus 22? That's just an 8. So that's good. And that's the end of our lesson.